Hi everyone, this is a second example that I am giving you for the analysis of asynchronous sequential circuits. So in the previous example of mine, if you see, the Boolean expressions were given and we formed the logic diagram. Here in this problem statement, the logic diagram is given and what are the things we have to do? I have written the right hand side, things to be solved. We have to write the Boolean expressions, state table, K maps and then the transition map. In the previous problem, the output expression was given, so we have to form the output map according to that problem. Here there is no output expression given, that we have only the next states and y1 as the output, y2 as the output. There is no separate z expression as given in the previous problem. So there is no necessity for output map here. So in order to write the Boolean expressions, first we have to write the output of each logic gate. That's what I have given here. If you see here, to form the Boolean expressions, find out the output of each logic gate. So first AND gate, what is the output? What are the inputs y1 and x? Therefore, the output is xy1. And then for the first inverter, it comes from x, so the output is x bar. Similarly, for the second AND gate, it is x bar and y2. And then for the second inverter, it is y1 bar. You can see it comes from y1, so it is y1 bar. And for the third AND gate, it is y1 bar. It starts from the x, you can see here. It starts from the x and it is output is xy1 bar. And the two outputs of OR gate, you know it is a plus operation. So xy1 plus x bar y2 is the inputs or the two inputs of the first OR gate. And for the second OR gate, x bar y2 and xy1. So add up these two for the second OR gate. And we get the expressions for y1 and y2 that I have taken and written here. y1 and y2 are the outputs of the logic diagram. Okay. So here x, y1, y2 are the inputs or else we can call them to be the present states. As it is a sequential circuit, we have the two states, present state and next state, which we do not have in combinational circuits. And then y1, y2 are the outputs and they are called as the next states. The next that we have formed is the state table. The state table gives us the relationship between the present state and the next state. It also tells us if the state is a stable one or unstable one. So if the present state is equal to the next state, that is the lowercase y1, y2 is equal to the uppercase y1, y2, then it is said to be a stable state. If they are not equal, then the state is said to be unstable. This I have given clear definitions in the problem 1 of my video. You can refer that. So now here, substitute in these Boolean expressions y1, y2, the values that are given in this present state, that is the inputs, and find out the values of the next state y1 and y2. Substitute for x, y1 and y2. Okay. Why have we taken 3-bit combination? I have given there note in the note reference for your reference. There are 3 inputs, so the integral powers of 2, it's taken as the input combination. So 2 power 3 is equal to 8 input combinations are considered. Okay. So 8 inputs are from 0 to 7. So substitute this y1, y2 in and x in the next state expressions, Boolean expressions y1, y2 and find out the next state. For example, if you consider the second one 0, 0, 1, what is it going to be? X, y1 is a AND operation. Again x bar y2 is another AND operation, and both of them in between has an OR operation. So y1 becomes 0 and y2 becomes 1. So similarly, it is so simple, and we can substitute and find out the next state. And as I said, when y1, y2 lowercase, that is the present state, is equal to uppercase y1, y2 next state, then it is a stable state. You can see the first one, y1, y2 is 0, 0, lowercase is, and the uppercase is also 0, 0. So it is a stable state. For stable I have given S, unstable it is US. So the third one, just check, it is 0, 1 in the present state. Next state it is 1, 1. So it is an unstable state. Check please the last one. The y1, y2 present state is 1, 1 and the next state is 1, 0. So it is an unstable state. So this is the way we frame the state table. The state table is similar to the truth table in the combinational circuit. The next step is to do the K-maps. Because we have 3 inputs in the state table, we take 2 power 3, 8 is equal to 8 cell K-map. So the K-maps are worked out from the state table. We are very familiar with K-maps, so I needn't explain it to you separately. So see the state table, the present state y1, y2, x. That's what are the inputs to the K-map, y1, y2, x. For that, what is the value of y1? It is 0. Write it in the first column. And then similarly, the second one, 0, 0, 1. For the present state, the next state y1 is 0. Write it in the second column. Similarly, 0, 1, 0, it is 1. So you should write it in the fourth column. 0, 1, 0, it is 1. And then 0, 1, 1, it is 0. So the third column in the first row, it is 0. So there is another easy way to work it out. You would have known it already. You can see the y1 here. Read it 0, 0, 1, 0, 0, 1, 1, 1. So you go to this K-map and we know the cell numbers. It is 0, 1, 2, 3 and then it is 4, 5, 6, 7. So you can write the outputs y1, vertically read it and write it here. How? 0, 0, 1, 0 and then 0, 1, 1, 1. Similarly write it for y2 also. Then, so the K-map is done. And what is the transition map? From the K-maps, the first 2 values of the first 2 columns of y1 and y2, take it and write it together in the transition map. So first it is 0, 0, next it is 0, 1, next it is 0, 1 and the fourth column it is 1, 1. And the second row similarly 0, 0, 1, 0, the fourth column is 1, 1, the third one is 1, 0. Now we have to look into the unstable and the stable states. So circle up the stable states. We know from the state table which are the stable states. We have just 4 unstable states in the state table. Similarly here we have 4 uncircled states that are the unstable states. The circled states are the stable states. And here we don't have an output map because we don't have an output expression separately. When I say y1, y2 as outputs, they are the next states actually. They are the intermediate outputs. Maybe they are the next states, you should say it. And there is no final output Z from the logic diagram or in the expression like in the case of previous problem. Okay, so we should have that in mind and we need not do the output map. So with this the analysis ends. If you have any doubt, please post it in the comment section. Thank you.